Hi, this is Rahul. In this lecture, I am going to cover breadth first search. So before going to breadth first search, we first know what is graph here, how do we actually represent the graphs. Then only I will cover the breadth first search. Suppose we have a social media network, it is made of five persons. You can see we have five persons and set of ages or what it means they among them what is the friendships. Suppose one guy is have friendship with two and two has friendship with five and one has friendship with four. That way we have formed a network, right? Suppose if you write your friend name in the searching box of social media networks, you click hit button of searching. What do you get? You get the answer of your query. Do you know what is the algorithms running behind? There is some searching algorithms, graph searching algorithms are running behind to get answer your query. So before going to searching algorithms, we first know how do we actually represent this graph in computer so that we can easily process our idea. If something question being asked related to graph, then we can answer it. So what is the how what are the ways to represent this graph in computers or math or so that we can answer or we can make algorithms for the graph. So there are two ways to represent this graph. First one is a adjacency list, second one is a adjacency matrix, right? First one is a adjacency list, right? Adjacency list is what? Suppose this is the one list and in list start from one. What it means, this first list has how many elements? 2 and 4. What it means, 1 is connected with 2 and 4. That's why in first list we have 2 elements, right? And second one, what it means, second vertex, how many is our neighbors? It has 1 and 5 and 3. These are the neighbors and they are connected to each other. And in other way we can write in like this. There is another way of writing, but this is a one way of writing where we can use the linked list data structure, right? Third list you can see over here, the neighbor of 3 what are in this graph, 2 and 5. So that says the reason 2 and 5 is the neighbor of 3. So that's why we have included the number of vertices in list 3. Now we'll see what is vertex 4 and list what are the vertices in list 4. We have 1 and 5. So in this way we make an adjacency list. Now we'll look at the most important representation of graph is adjacency matrix. This is very important. Why it is important? Because lots of the mathematical methods of process being developed for matrices. So that's why if we have mathematical matrix representation of a graph, that would also 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 provides us to implement the strategy what are present in mathematics, right? So that we first know how do we actually make a matrix by using this graph. So we have a rows. You can see over here how many rows we have. You can look at the number of vertices in the graph, 1 to 5. These are the rows we have. Number of columns we have 5 because the number of vertices in the graph. So we in this way we have n cross n matrix, or in other way in mathematically we can say a square matrix we have, right? So the size of matrix is n cross n. N is what? Number of vertices in this graph, right? How do we actually fill this graph? Diagonal cells I will fill here 0 because of there is no self loop. So that is the reason I have filled all the zeros in diagonals elements of this matrix, right? 1 2 we'll look at we are going to see how do we fill other entries. 1 and we'll see first one row and second column. So for this entry, what it means, are they 1 and 2 connected? You can look at this graph. What do you see? Yes, they are connected. So that's why we filled here 1 and 2 3. Are they connected? 1 and 3, they are not connected directly, so that's why we filled here 0, right? 1 and 4, are they connected directly? Yes, they are connected, so that's why we filled here 1. In this way we can fill all these entries in this matrix. So this one, we are going to use this type of representation in all the algorithms which are being covered in my lectures, right? So we first go through the first algorithm, which one is the best first search algorithm. Before going to best first search, we must know what is the meaning of breadth, right? Suppose you can see this is the one space, 2D space. You can see in form of a grid I have made it, and there is a one coin which is present here, and our task is to figure it out where it is, I mean searching. So the searching, the strategy we follow breadth first, right? What it means, from here we start, and we can start from anywhere, but I am randomly starting from here, right? There is no particular way where to start, because at random we don't know where the coin is present. So we started from here, and what we see around this, we explore all the vertices, all the free locations around it, right, where we can move. So at point t0 we explored these locations. At time t1, what we do, from here we explore all the vertices, all the free locations. At time t3, what we do, from here we explore all. So in this way, what we are doing, we are moving forward, to another levels. But before, suppose before 1 2 3, so 1 2 3, suppose we are moving from level 1 to 2 and 2 to 3, this is not possible at all. First, if we are going to level 3, first we have to explore all the vertices of 1, then only we can explore all the vertices of 2. So in this way, breadth, we have to first explore the breadth, then only we can explore another levels of breadth or another levels of neighbors. So we'll look at all these things in graph, so you can understand very easily. If you have not understood it, then you can understand very easily, because for graph it is very easy one. We suppose we have given a graph, you can see over here we have this given graph, and we start we start processing breadth first search algorithms. How it works, let's see. We have a graph, we start randomly, as I told you, we start from anywhere, and then in graph I'm starting from here, right, from vertex 1. And same times, what which is very important, we will keep one array a. What it means, if we are exploring any vertex in this graph, then we will put in this array. So that is the reason we are taking this array, right? So we will move forward and see how these algorithms work. There is some notation. This notation means we are going to explore all the vertices around this vertex, and this notation means, what it means, this is vertex being explored, right? And when we explore the vertex, then we will put in array, right. Suppose we started from 1 and explored vertex this one, these two we will put these two vertex in array. 4 and 2 we have filled in array, right? There is no order among the neighbors of 1. Either you can put here 4 to 2 or 2 to 4. There is no order, right? So once you have visited 4, then again what do you do in next step? What do you do? How many elements you had in array A? You had 4 and 2. Now before, from the beginnings, you will find out which the neighbor of vertices which are not visited. What will you see? Neighbor of 4 which are not visited. So that's why we start exploring from 4. What we see, we explore this one, and the vertices which are explored by 4, we will fill in this array from at the end of the vertex which are present, right? So after 2 we will add 5, right? You can see for here. In next step, what we do, what we see here, for 2 is there, right? From 2, what we explore are the neighbors of this vertex. Why we have selected 2? Because 4 and all the vertices around 4 or neighbor of 4 were already explored, so that's why we have picked next 2, right? Around 2 we explored all the vertices. What we see, T3 was the vertex which was not explored. Now it is explored and we will add this array, right? Now in next step we repeat the same things. We explored next one. From this one we try to explore all this, but what we see, but this all the neighbors of 5 was visited. So that is the reason we keep doing all those things. We will visit 3 again in the last step. Here we will stop because all the vertices are visited or explored. So one more thing very important, which are most of the times asked in exams, what is the behavior of this array? Which very important one. So behavior of this array is what we are doing. How are we are using this array? There is one very important thing with this array is we are inserting a vertex at the end of this array. From this side we are inserting. What it means, so if we are exploring any vertex at any point of time, while exploring we are inserting at the end of array, right? And second operations which are performing on this series is what we are removing vertex at the beginning of. From the beginning of this array we are removing. You can assume while I am making a red one circle, what it means, these vertices are removed. No need to worry about all those things. But if this type of operation you are performing with any array, you will name it Q. There is one data structure which will allow these type of operations, which is what we call as Q. You always remember, we call it as a Q, right? So in other words, we can say breadth first search uses Q data structure, right? Now we will go through the time complexity, how much time would be taken by this breadth first search algorithm. We will go through the process how the breadth first search has been executed previously, and we see how do we compute the time complexity, right? See, in each iterations, what I am doing here, we are simply marking it by red marks. You can see here by each iterations, right? So we started from 1, and what we see, 1 is explored, and 2 and 4, these are the visited. And what it means, iterations 1, 2, 4, these are vertices we have visited, right? And at the same times we have also visited what edges. You can see here these 2 edges we have visited. And next explorations, what we do from 4, what we do, these vertices I have cut it down, right? At the same times, what we do, next iterations, what we do from 2, we have explored these vertices. In this way, I'm going to, this is the way how the breadth first search algorithms execute. What we see, you can do yourself. What you see here, the number of edges we have 7. You can compute it. Number of elements in this A set is 7, and number of vertices in this vertex set is 5. We will take the maximum one, and because always we compute the time complexity in worst case, so that is the reason the time complexity in worst case would become so the kernel of V plus kernel of E. In other words, we can write max of E or V, because see here we are visiting all the vertices in breadth first search. So that is the reason either any graph there may be possible cardinality of E equivalent to cardinality of V. If these two cardinality are not possible, then the number of vertices, maximum of number of either edges or number of vertices will be the time complexity. This is how we compute the time complexity. If you find this lecture is helpful for you, please like and share with your friend. Thank you.